Hi, this is Nick Gross with B-Team Engineering, and we're going to talk about your new auto drive, or if you're investigating the auto drive system. So the auto drive system works as a universal system. It's the same core approach for both Mark 7 products and Dillon products and any other press out there. The core difference, though, is how you interface the drive to the press. So we're going to focus predominantly on what you got from our shipment, the build quality, inspection, shipping, and then we're going to talk about how to attach it to your press, how to tune your press, and then hopefully by the end, how to load your system. So when you get your system, they will come in a 20-inch by 12-inch by 18-inch box. Everything will be shipped correctly, and hopefully all components will be present. If you get through the end of this and you discover you're missing something, please reach out immediately through our preferred contact points, which is the website or email, and we'll get you fixed right away. And I'll preemptive with an apology right now if that happens. So let's start out with what we got in the box from a small perspective. We're going to start with our set of fasteners. The machine itself is all going to be based from an M6 fastener with M6 fasteners. So you'll be given 4 flange head M6 by 1 bolts that are 20 millimeters long, along with set of flange head nuts. Next, you'll be given a set of 16 millimeter flange head nuts, still M6. From there, you'll be given another 4 socketed cap screws, M6. These are 35 millimeter with their own flange heads. And then lastly, you'll be given 4 40 millimeter, I think they're 40 millimeter, I'm guessing, socketed cap screws. Now, the 1050 and 1100 are similar presses, but they vary in a few ways. Now, the big variance will be one of the big variances will be these bolts. So the 1100 is longer than the 1050. We provide both 1100 and 1050 bolts with your package. It helps with our manufacturing, so you will have extra fasteners if you do. Just take it as a friendly gift. Along with those, you'll be given 4 washers, a set of washers for your press. This will help with preventing marring and other things. They are blue zinc. So that'll be the small fasteners. After you've kind of done an inventory on your small fasteners, you're going to look through your box for a certain set of cables. So the first cable you're going to look for is your HDMI, or your HMI, not HDMI, HMI cable. It's going to be a 9-pin D-sub. This will plug into from your control box to your touchscreen. Along the same lines, you'll also have your touchscreen. As you can see, you have your emergency stop button, touch display, and its plug-in port. Along the same lines, you'll notice that there's another slit, and that's for future programming and updates. We'll cover that separate. Lastly, once you get the system, it's important to inspect that the entire system arrives in perfect condition and without any cracks or damage to the screen. The screen is not salvageable if it is damaged or crushed in, and you need to immediately reach out and we will replace it. All right, that's the touchscreen. Next item that you'll find is a bag that'll be labeled for your proximity sensors. This bag will have 2 green tip proximity sensors or inductive proxies with their connecting hardware, their mounting bracket for your press, and the flag that you put on the press. We'll cover that once we get to that stage, but they'll come packaged together. Next, you'll also get a bag with your complementary bullet orientation sensor. Same thing, you'll have your press mounting bracket, which will be a piece of aluminum, bent aluminum, a mounting adapter, and then the laser sensor itself. Those will come packaged together. Lastly, from a cable perspective, you'll be given, depending on if you're in the US or in Europe, your own cable, but you'll be given a cable that is designed for a 110 or 220, and then it converts it down to a normal computer-based power plug. So again, that covers the cables. Now moving on to the bigger items. You'll get, when you open your box, you'll be presented with this control box. This is denoted as a control box. You can call it the toaster. You can do whatever you want. This box comes with 2 external cables that are hardwired in. These are for your stepper motor. You'll have a 4-pin and a 15-pin. On the box, you'll be presented with your power switch, input fuse, and a power switch. You'll have your 6 plugins, 4 for your sensors, 2 for your proxies, and then you'll also have your HMI plug-in. Lastly, just a note, at the very top, I don't know if the camera can see it, you'll have a programming port. This is a micro USB, and you'll use that for programming the box. The box and the touchscreen have their own firmware updates. They're fairly simple and automated, but they are separate. That's the control box. After the control box, the next big item is going to be our NEMA 34 stepper motor. It'll come packaged in the following package as you see. Along with that, you'll see a red bag. This red bag houses the key for the stepper motor. Don't lose this. The motor will come packaged. I recommend you inspect the connectors to ensure they arrived alive and everything is good. Once you're there, I would set that aside. After the stepper motor, you're going to look for the next box, which is going to be your gearbox. The gearboxes come prepackaged on their own. They'll come with a bag of fasteners, and they will come with the gearbox. For the video, this is blue, but you can get the gearbox in either blue or silver, or red even. Most of the time it's blue or silver. Just a note for the gearbox, the bag of fasteners is from the OEM. We will not be using these. It's considered another free gift. You also are given a vent plug. The vent plug will not be used as well. These gearboxes do require occasionally oil changes, and that is going to be these ports. We cover that in the manual, but just for your data. Lastly, from a gearbox perspective, the placard on here will tell you which ratio you have. We do ship the base unit at a 1:20 gearbox, but if you subsequently want a 1:30, 40, or 50, that's where the placard will be. The system will come shipped with our universal L brackets. These L brackets are designed to fit all presses. They will mount to your machine, and your gearbox will mount up on the plane. Depending on which press you have will dictate which holes, and we'll cover that during the assembly. But these L brackets are universal from forward and back, and they can be mounted either way. You'll have a set of 2. Along with those L brackets, you'll be given a bag, another bag that will come with 2 shafts. You'll come with the shaft that's proprietary to your press. The 1050 shaft and the 1100 press shaft are different. This one is for an 1100 CP2000 and an RL 1050. And then this shaft you see in here, and we'll pull it out later, is for a 1050. They both have the same coupler, which you can see here is a split coupler, and then you'll get a set of keys. The keys on this are all 6mm. You'll have 3 small keys and 1 large key. And then you'll be given an 18mm shaft for the gearbox. These will all be packaged together, and will come from there. Along those lines, the last thing you'll get is our universal aluminum mounting plate. This is a 6061 plate, so feel free to drill your own holes in it if you want. It's fairly simple. All fastener holes on this are M6 and M8. For the 1050 and 1100 presses, you will not be using the M8 holes. Those are for the Mark 7 customers. You can see the holes that you will use will be this group of 4 and then this group of 4. Lastly to note, you have an unthreaded hole at the front. This unthreaded hole dictates the front of the plate for your assembly. If you're mounting the system in a configuration where the press and the gearbox are here, it'll be this way. If you're mounting in the reverse configuration, it'll be like here and here. This hole notates or dictates the front of the press. All right, that should cover everything you were shipped. Let's get started. So first thing we're going to grab is our mounting plate. We're going to put that cleanly down. For the sake of this video, I took the case feeder off and everything, but with the actual press itself, I recommend that all components, primers, bullets, brass cases, everything are removed just to make your life easy. And what we're going to do is we're going to take our 1050 and we're going to take the handle off first just to make our lives easy. We're going to line it up. You'll see the 4 holes, and we're going to line it with the press. We're going to take our blue zinc bolts. We're going to do the first one in the corner. This might be a little tedious for the first one, and we're going to hand start it. And we're just going to hand start all 4. And we're just going to kind of work our way around, see how much air gap we're leaving. If you need to wiggle it, there is going to be play in the system. The holes are designed for a 1/4-20 fastener. But if you need air gap, let's make sure, see if it's the right one. So what we're going to grab is our M5. We're going to grab an M5 or number 5 Allen key. And we're going to put those in, and we're just going to kind of get them down so that they're relatively close to the bottom, so they're not as high, to make sure we're fully engaged. Shouldn't have any resistance, shouldn't have any chasing. If you feel like the thread holes are rough or gritty, I recommend you stop and take the system off and just thread chase the fasteners. Sometimes there could be a mess, there could be other things in there. Who knows? You know, manufacturing occurs. There. So the press is still loose. These are finger tight. And we can wiggle the press minutely. That's going to be snug. At this stage, what we're going to do is we're going to decompose the press. So we're going to take the press apart to get it ready for the auto drive. So the big thing to remember with the auto drive for the Dillon family of presses is we'll need to replace the main crankshaft with our provided shaft. This is a 4140 shaft with its own keys and everything. So we're going to replace it. And again, this is the one for the 1050, and then this is the one for the 1100. You can kind of see the difference. Relatively close, but relatively different. All right. So first thing we're going to do, it's pretty simplistic with the tool head down in a downward position. We're going to undo the retention bolt on the side. Let's turn this again. We're going to remove the retention bolt. I've already pre-loosened this. If these are pretty snug, you might have to work them off. We'll remove the retention bolt, and we'll take off the head spacer and bearing. With that, you'll have a captured bearing. So at this stage, get some stuff out of the way. I recommend you take your swage rod and you undo your swage rod, turn it sideways, pull it off, put it off to the side so we don't lose it with the rest of our stuff. You can leave the rod in there if you want. It's up to you. It comes to your preference. At this stage, what we'll do is we'll lift it and we'll just pull this out. If you need to, take your hand and just kind of play with it. Oops. And you're just going to pull the system out. So when you pull out your Dillon crank, it'll look like so. It'll be messy. You'll have your keyway in there. We're going to take that key, and then we're going to take our shaft. We're going to put our shaft over here. Our bearing and assembly should still be in the system. So at this stage, what we'll then do is we'll take our new shaft, we'll put the keyway on, and then what we're going to do is we're going to look down into the system, and we're going to locate the key in the lower crank, and we're going to play with it. It might take a little bit of playing to line it up, but the key should go all the way in. We'll take our bearing cap, install it back on the side, and we'll just snug it up. I generally will tighten this later. I like to tighten everything later, but the system should be cleanly in there. Now for the 1100, similar steps. The only difference with the 1100 is that when you pull it out and you do the key, you'll need to put the idler bearing that will be on there first, and then you'll put the key, just because the shaft is one step the entire way. Same approach for the bearing. Same approach for the bearing cap on the end. Just fasten it on and you retain it. With this all mounted, I generally at this phase, since we'll add more, we'll put the swager back on there. If you want to, you can put your swage rod in or anything. I'm going to leave it off just for the sake of the video. And then you're ready to go. So now with the press ready and everything, you can decide if you want to move forward from here, leaving your tool head on or anything. Feel free to do as you wish. I normally leave my tool head on. At this stage, what we're going to do is move from our press assembly into the rest of the drive with the gearbox mounting and everything. So what we're going to need for that is our two L brackets, our gearbox, and then the rest of our equipment. We're going to get started with mounting the gearbox. There's a little bit of pre-work on the gearbox. There's a few different ways to skin this cat, but we're just going to do it this way. First, just to note on these brackets, for the 1050 users, you'll be using this lower lobe, or this slot. The 1100 users use the top. It's really the big difference between the two systems is that location and then your shaft. Everything else between the two is identical. So we're going to start by fastening these brackets to the gearbox. We're going to grab the 20 millimeter M6 flange head bolts. I find it easier to put them in with the flange head inside of the system and then holding it with the back. I'll turn this because you better view with the back, and then starting the nut on the outside and just kind of getting it finger tight. We don't need this to be snug or anything else to push a bias into the system. We'll grab another one, do the reverse on the other side. And we're just, again, going to snug them down. If you want to, you can do some lock nuts. You can do whatever you want. Absolutely, in no way, use Loctite. If there's ever an event from a maintenance perspective that you have to change or fix anything, Loctite will not be your friend. So, just a note, because these gearboxes are made overseas. Sometimes the castings might be a little undersized. If that's the case and the bolt doesn't fully get in, feel free to take a 1/4 20 drill bit, just drill it out. It's aluminum. They're really there. You're not going to hurt it. You're not going to damage it. I know it's not copacetic, but it's the nature of the beast. So with the system, you'll have your gearbox set up like so. A little bit of play. We'll take our gearbox and we'll just do a quick spot check, make sure everything's aligned. Keeping them to make sure you should be visually able to see it. Everything there. Next, with everything on there, we're going to take our bolts and we're going to kind of just stage them. Before we do all that and mount it, we're going to pull our coupler out, our keys, put the bag off to the side, and then we're going to take our shaft. As you see, we'll install the keys. If my hands worked right. So that you have 2 of them. Obviously, these keys are mismatched, but you'll have a key that actually fits the slot. And then this is just a spare I had. And then the other. This will mount in the gearbox like this with the shoulder. I generally recommend you take this shaft, push it into the gearbox. Should be loose. If it's snug, feel free to use a dead blow or soft hammer. Along the same lines, I recommend taking the clamp shaft. It's a split shaft, loosening the tension so you have play, and starting that on the on there, and just kind of get it out of the way. Leave it loose. You will snug it up later. Once that's done, I recommend taking the last key onto your shaft. You can see how it is upside down in here, and we can kind of see that our output shaft key is out. We're going to turn this manually at the input so that is upside down. I can't see it for the camera. Also my bald spot. And we're just going to turn it so that we're relatively close. We'll take that insertion and we'll slide it on. This is obviously very loose. The press is too. One note, I know this is a design flaw and people are not happy, could not be happy, but it's fairly hard to pull off get your swage knuckle off without pulling this whole thing apart. It's just the nature of the design. But that's why I want to make sure this is on. Now with the system on there, we're gonna move it back and align, and we're going to line it up with our mounting holes. Now, before we start or do any of that, with everything snug, we're going to manually move our press so we can get access to these fasteners very carefully. And what we're going to do before we tighten anything up or install anything is we're going to snug this connection. I generally recommend getting it all the way on the shoulder and then using the aft side of the shaft to push it forward and in so we fully grip or hold the shaft that we're attached to. So what we're just going to do is we're going to snug these up. Remember, doing top and bottom at the same time. We're just going to snug them up, and what you're watching here is it's going to force the bore of the gearbox to become concentric with the bore or the center line of the actual press. That's kind of what we're doing here. It's kind of just the nature of the game. The auto drive and the fastener approaches and the brackets are designed for this to float to this. So regardless of tolerance or misalignment or anything, the goal is for this shaft to drive the center of this, and then we'll fasten that down on the plate. It's kind of why we leave everything loose. You can come back and tighten these up later. These need to be snug, just enough to ensure that you're fully seated on the shaft. We're kind of good. Figure it out. With that, we should be lined up, which we are. We're going to take our M6, our 16 millimeter flange heads. We want these to be loose, kind of hand tight. If you want to, feel free to use an impact drive or anything. You just want to overdrive. I'm going to use this ratcheting wrench. These are all 10 millimeter flanges. So I'm just going to ratchet it down, starting with the front. Ideally, when you do this, you'll be facing your press and not reversed, like myself. If you're curious, it's not as much fun as it sounds. So we got the front 2, we're going to do the rear 2. Kind of work our way around. Cool. Now with the system here, we're kind of loose, we're playing. What I like to do is I like to move the gearbox. You can see how it rattles. So with that little motion, we're just going to work it free. And what we're going to do is come up to the top, and we're going to snug up the gearbox bolts on the system. I started in the back because that's where I was, and we're just going to work our way around. We're again just going to snug these up. I wouldn't go overkill at the moment. We'll come back and do a final kind of torque tight on everything. But right now we're just getting them generally where we need to be. Here's our gearbox. We're secure. You can kind of move it, see the motion. With that tight, we're going to come back to our base bolts, and we're just going to give them a nice little snug just to make sure we're good and we're retaining. Cool. With that, gearbox is on. Gearbox is on, coupler's there, shaft's been replaced. Let's add a motor. So again, the motor will come in this packaging. We're going to take our motor out. We're going to grab our red bag. We're going to take the keyway, and we're just going to push it in. It should be pretty soft. We're going to take the motor. We're going to line it up. We're going to drop it down. The beauty of this motor, it doesn't matter if you want your motor cables off to the side, up to the front, or to the rear. I normally go off to the rear because then I'll come and zip tie these down on my own time for leisure. With that, we can get rid of the packaging. Feel free to keep it. Feel free to throw it away, whatever you want to do. Now, for the next step, we're going to secure the motor. So we're going to take our socketed cap screws, and we're going to drop all M6s into the holes. They should fit snugly or loosely. Make sure they're good. We're going to take our the flange nuts. We're going to start in the front just because these are not the funnest to start. And we're just going to kind of hand start those. If you want, you can use a wrench, whatever works best. They are Allen keys, so if you want to use a ball nose Allen key, which we'll do here in a minute. We're going to get those hand tight. We're not going to snug them up yet. Just a note, when you run your machine, if you hear resonance, it sounds, how do I describe it? It sounds like a tuning fork of the machine running. Sometimes if you have an uneven tightening where all 4 bolts, 1 is super tight and 3 are really loose, you potentially cause a misalignment, and that causes a weird sound. So generally what I recommend is if you're hearing weird resonance-based noises, is to loosen everything and run 2 or 3 cycles, no load on the shell plate, and just let the system naturally hone itself. Motor's on. We're going to take our Allen key with a ball nose, if we get the right one. We're going to put the ball nose in there. If I can just get it. Our ball nose. Take our 10 millimeter, and we're just going to snug these up. With that, motor is attached. We should be secured. This is play that you're going to see in the gearbox. And in particular, it's really just this gearbox that you see in the video, but you should be fairly snug. All right, with that, we're going to move on to installing our proximity sensors so we can get this thing running. We're going to grab our bag of proximity sensors. We're going to pull out the prox bracket. Prox bracket, our 2 proxes. They are identical to each other. And then we're going to grab our flag. And then you'll have an M8 bolt that we'll use to secure the flag to the base plate. All right, well, let's get started. I generally recommend that you pre-install the inductive proxies into the bracket before putting it on there. You can do it when it's on there, feel free, but it's a lot easier just to start it on the bracket. Now, we'll have a better diagram within the manual for how to remember this, but the best way to remember 1050 versus 1100 is that these top 2 are for the 1100 and these bottom 2 are for the 1050. Now, if you put it up there and it's too high, then it's you can figure it out. But we're going to take the prox, we're going to put the washer that comes with it, the clamp washer. And we're going to kind of put it at mid-span. We're going to kind of guess. It doesn't have to be perfect. You'll tune these when we turn the machine on. And we're just going to get in there. I recommend getting these snug so you have a good datum of where you're going to start when you start tuning the machine. Same thing. They'll come with these installed. Just undo them. Again, this is setting up right now for the 1050 configuration. Snug. We'll take our wires. We'll come off to the back of the machine. And we'll line up like so. There is a slot on this bracket so you can move it in and out. And it looks like this bracket's bent a little bit. If you want, that's aluminum. You can just bend it back, do whatever you want. So we'll put the bracket in. We'll take our M8 bolt. with the washers that are provided. And we will just line it up with the hole. And we'll just get her started. With this, we're going to use, once you get in there, we'll grab our Allen key, which this should be an M6 size key. And we're just going to snug it down. Obviously, the bracket just moved on us, but it's okay. Proximity bracket's installed. We're going to shift to installing the flag. Now, I'm showing this step after you've installed it as the worst case scenario. If you want to be smart or think ahead, you can take the bracket and put it on the shaft before you put the whole thing together. Feel free to do whatever you're comfortable with. But real quick, you'll get a proximity flag. So a 1050, an 1100, and Apex 10 will have a different profile depending on the press. They will be denoted with what model is on the side, and there is a part number on there as well. It's a two-part piece, but they function the same way. You have two, I would call them grub screws, and these are for fine-tune adjustment. Basically, if you need to increase or decrease the stroke, you can rotate them outwards or you can rotate them inwards as you're running the machine or tuning the machine to get perfect. So you don't have to tune or fidget with these. Now, real quick, we're just going to pull this apart so we can do a snap ring on it. These bolts are M6 or 3/4 inch M6 screws with a captured nut and a key. This flag is designed to break if you have a hard enough collision. Basically, if something breaks or shears, it's designed to fail. This is a consumable part. It's something that's easy to print. So real quick, we'll take the flag and we'll look at our markings. We have a B and a T, B for bottom, T for top. And what we'll do is take that flag and we'll orient it so that they're facing outwards. We'll come underneath. We'll kind of move it until we find the key. It'll fall in. Let's see if we can find that key. Hard to... Oh! See? You guys are all probably telling me where it was the whole time anyways. We'll take that key, take the coupler, and we will snap that in place. Sometimes the prints don't work well together, and what we'll do is just slide it in. The print is designed to be retention, so it helps you with your install. So if it's installed in this format, we'll take our screws, we'll just drop them in. And what we'll do is take our Phillips head from there, and we will tighten these. Now, I'll show you real quick what I have to do to tighten this back one because I didn't leave the press in a friendly configuration to reach it. Now, obviously, if you can't reach it and it's a pain, one screw is enough tension to retain it to get the press moved when you energize. But I'll take the screwdriver, I'll come up to the side, and I'll tighten it. If this prox bracket is in the way, feel free to remove it or unscrew it and do the flag first. Takes all day. You feel the flag snap, and now we're retained. So system's there. We've kind of lined it up with our sensors. If they're not perfectly aligned, you can move this flag in and out and this bracket as well. The sensor head just has to be within this region to read it. Doesn't have to be perfectly centered, just has to be close. All right, so with that, we have our flag, our coupler, our motor, and our press, and everything ready to go. Now let's shift to turning the system on and plugging everything in. Let's start by getting the machine ready to go. We're gonna start pretty quickly here by hooking up the motor first. It's just, kind of order op. The motor cables are independent of each other, so you can run them separately or together, but you're gonna take your motor cables, which are going to be your power cable and your encoder cable, and you're going to match them to their partner on your machine. So when you connect these, the encoder cable is a 15-pin D sub, and the HMI touchscreen cable is a 9-pin. They won't mix together, they won't connect. So if you have that problem, I would count the pins. So we're going to take our 4-pin, there's a notch, and you're going to screw it together, and your system's ready to go. Now, on the box, we're going to move to installing the proxes. The proxes will go into one or two on the bottom. They are noted or labeled on here. But the best way to kind of run this is we start with the top. We'll take the cable. We'll just kind of chase it out. We'll take our prox cable, and we'll plug that into 2, which is for the top sensor. That will measure the tool head at the top position. Next, we'll take our remaining, which is our bottom sensor, and we will plug that in as well. With those, the proxies are set up and ready to go. We'll move the cables a little bit out of the way. Next, from there, we'll move into the touchscreen. We'll take the cable will be fun. We'll take the 9-pin cable, we'll line it up with its counterpart on the control board, and we will plug and screw that in. Once in, we'll take the other end. We'll take our touchscreen. We'll plug it in accordingly. And then we will also retain those. Yeah, get close to the board. With that, our touchscreen is connected, our motor is connected, and our proxies are connected. From there, our last thing to connect is our power. So obviously, if you're a 220 user or a 110 user, your box will be configured that within the box. So we're going to take our plug, we're going to plug it into our outlet, and we're going to push that in to the system. So again, power's in, switch is on the off position. When we energize the machine, it's fairly easy. It'll illuminate. When it does, you'll get a energized power of the screen, and then you'll also hear your motor engage. You'll hear a light click. So we've turned everything on. We have the box running, motors engage, everything. We're going to start by kind of looking at the touchscreen. Your menus, you present with 3 buttons. You have your fully automated run, your semi-automated run, and then you have your settings. On top of that, you have an e-stop. So real quick, what we're going to do is we're going to take a look at the machine and we're going to check it. We're going to go to our manual drive, we're going to hit the 50, and we're going to do one little up push. Once we do that, we're going to hit the e-stop, and then we're going to grab our wrench and we're going to come and fasten our press downwards. I recommend doing one small motion travel like so to force the alignment, if anything else was out of it, into sync with the machine. Now, if you want to do this before you get here, that's perfectly fine. This is just what I recommend doing. I just kind of keep tightening her up. All right, so now what we're going to do is we're going to hit bottom and home, and we're just going to watch it drive down. It should drive to the sensor and stop. We need to confirm that it went to the right spot, so we're going to take the press, and we're going to look at the back. And I'm just going to show real quick with an Allen key, but you should see an air gap. Let's see if we can do this correctly. You should see an air gap between the bottom knuckle and the hard stop. You can get close if you want. You can have it. I recommend not colliding with it. And it ultimately induces more wear into your machine over time. But that's the kind of the landmark you're looking for. Now, real quick, I'm just going to show this approach, doing the same approach of what the setup on the RL1100. We just did the 1050. We're going to pivot over to the RL1100 and CP2000 for this. I'm going to show you what the bottom position should look like. On the RL1100 and the CP2000, your hard stop is actually the bottom of your frame down here. So real quick, just going to show it. I have the system set to home on the bottom, and we're just going to slow drive it down, and we're looking at this interface. As you get close, you really just want to hit stop, and you will look for an air gap. I can put my finger in there. Let me rephrase that. I'm putting my finger in there to show you. Don't put your finger in there. But what we're going to do is we're going to get close, stop it, and we're going to hit the 5 iteration, and we're just going to pump it down until we're just about to touch where we should have an air gap. Keep going. And that's probably good enough. You can go a little bit past. The goal is not to have the eccentric contacting the frame. It's not the end of the world if you touch it, but it adds duty life to the machine if you don't touch it. All right, we're at the bottom. For the top, we'll do the same thing. We'll just kind of go up on this machine. You're going to watch your indexing lever. A good way to tell if you're fully going correctly is you look at the shell plate. We stopped it just before full index so we can have as much control as possible. And we're going to hit the 5, and we're just going to pump it up. I usually take this lever and try to feel how tight it is. See, I have a little bit of play. You're kind of playing with that distance. Lastly, on these machines, just a note, there is a hard stop for your index. You can leave it in if you wish, but I usually back it off a little bit just to prevent the machine from overdriving and getting a premature seat fail. But I'll leave an air gap, which is what you just saw. So that should be it for an 1100 and a CP2000. So we just came back from the CP2000 and 1100, and now we're back to the 1050. So on the 1050, we set the bottom's good. Now let's jump to the top prox, and we'll set that. So real quick, you can do this a few ways. You can hit the 50 and you can just jog the machine upwards manually if you wish. I like to hit the top and home, and I will ride the e-stop button until I get close. I generally look for the shell plate to start the index, just like that. I'll push the e-stop, we'll stop it, and then I'll hit the 10, and I'll just slowly just walk the system upwards. And what I'm going to do is check the rear index, and our rear index is tight. I'll hit a 5. I'll change to the 5, and I'll go down 1, and we'll kind of play with it. So if we look at the system right now, our prox is not aligned. Our red indicator light on the top prox is still energized. So what we're going to do, similar to what we did on the bottom, is we're going to loosen the nuts, and we're going to basically loosen the rear nut of the prox, and we're going to unthread it so to pull the sensor forward or towards the flag. And we're going to look for that red indicator light to turn off. There we go. And we're going to do that. And once we're there, we'll snug it up. We'll get close. Perfect. We'll do 50 and we'll go down. With the system still on top, we'll hit home. And we'll check to make sure it's there. If it's not as tight, I recommend doing another set of 50. Just enough that you can get a screwdriver in here. And what we're going to do is we're just going to turn it in to either increase or decrease the length of the screw. And this will give you a fine-tune adjustment without having to adjust a proximity flag. So we'll hit home, we'll re-home again. So with that case, we actually unthreaded it, which meant our shell plate didn't fully index. So what we'll do again is we'll just hit the 50 and go back. And we'll just screw it in more. Let's hit home. We're watching for that full index. So like there, the system is really tight, but we did stop. The indicator light is off, but we want to get it a little bit closer. So we're just going to kind of keep working it. I know this looks impractical, but it's one of those things that you want to take your time to get right. So we're going to do about half a revolution just to get there. We'll hit home again. We're looking for that full index, right about there. We're good, nice and tight and snug. We have the sensors. So with that set up, I hit bottom. We watch the machine index to the bottom. We'll make sure it's a clean show. Nothing stops, nothing happens. Now, while you're running this, if for some reason the machine stops abruptly without reaching the home sensor and just stops, I recommend you try rehoming and going. But if this continues, this is kind of a symptom of potentially a loose wire on the proximity cable or potentially a bad prox. These proxies are made in China, and the likelihood of a defect is there. So that's an easy symptom to identify. We just went down, we went up, clean index, clean bottom stop. I think we're good to go learn our machine. So I'm just going to pull it off the top just so you can see what the machine does. You don't necessarily have to do this. But with the tolerances of this machine, other machines, and everybody else, you have to teach the distance of travel the motor's going to have to go. This also feeds back into the modular gearbox approach. But we're going to hit the back arrow. We'll put it up here, the back arrow. We come out of the main jog, we're going to hit stroke setup. And when we hit start, the tool head will climb. It'll zero itself, and it'll drive all the way to the bottom. That distance is what it learns as the travel stroke. And I'm going to show that real quick. We hit start. We go up. We're going to go down. Now, at any time, if you hit the emergency stop button, it'll stop this, and it'll cancel it out, and you have to redo it again, obviously. But I recommend when you do this or anything, that you kind of have an empty shell plate, an empty system, no obstructions, and no load on the system. You want this machine to learn unloaded as your nominal, so when you do your clutches. So when you're done, the machine will drive back to the top of the learned value. We've just done it. We're going to check what we learned. We'll go back to that fast. We're going to hit clutch setup. We'll go through those in a minute. But you'll see the learned stroke value. That 1652 is the stroke value for this setup. Real quick, clutches, we'll just cover it since we're here. I have it nominally set at 125. If I want to change that clutch value to 250, I touch the value, I type it in, I hit enter, it changes it. The clutch values are not a force rating. They are a position rating. That's basically how far away can this flag be from the prox, and how long can the machine struggle to get that to the prox. That's all you're setting it up. This number correlates to how long the motor can spin for. So the bigger the value, the longer the machine's allowed to struggle. You don't get more torque, you don't get less torque. It's really just how long do you let the machine struggle from a position perspective. So that's the main thing. Now, if that's hard to think about, if you take this value and you divide it by this value, that is your percentage of clutch. So if 100% would be this at 1600, roughly. So hit save, we record the values, we're good to go. Let's go and teach the index. The index is where we basically index, we engage index to the shell plate. With that, what we'll do is we'll hit the start button. When we hit the start button, it'll take us to its own compartmentalized manual jog menu. And what we're going to do is hit the 50, and we're just going to drive down. And what we're listening for is a click for the paw. You can go lower, you can go higher. You can teach this wherever you want. Now, once we do that, it doesn't matter if you hit bottom or top. Just hit home. And the machine will drive downwards and it'll learn that value. When it learns it, it'll drive back up to show you the value it learned. All right, so our top and bottom procs are set up where we want them. This press cycled the way we wish or wanted it to. So now let's move on to teaching the stroke and kind of learning. So real quick, just to understand how the machine works before we teach it so you fundamentally can follow. This machine is based off a total position. What that means is we know where the tool head is and we know where the motor is and we compare the two. If this is out of a position versus this, we know we have a problem. That's kind of the core of it. To do that, we need good values. So the first good value we're going to go for is the stroke setup. And the stroke setup is fairly simple. There's a 1, 2, 3 instruction on here. But what you're going to do is hit start. The tool head will move up, hit zero, will zero itself, and then go from top to bottom. And it'll record that value. When this value that's learning, as it tells you what it's doing, is learning the stroke of your unique machine. This is a 1050, an 1100, and an Apex 10 will have a different stroke value. If you have a different gearbox, you'll have a different value. And if you set up your proxies differently, you'll have a different value. So this is a unique thing to your machine. When it's done learning like it is, it'll drive back to the top, and what you're going to do is inspect to make sure it's stopped at the right spot, no binding, no issues. At any time during a stroke learn you have an issue, just hit the E-stop. It'll cancel it out and you'll just have to start over. All right, we just learned stroke. Now we're going to go to index. Index is a little different. When you hit start, it'll take you to a drive menu or your manual jog menu. And what you're going to do is hit the 50 and you're just going to drive the machine down, and what you're listening for is for a click of the indexing lever. It doesn't have to be perfect. You can kind of guess it. I like to set mine up just before, tension on there. And that's kind of where I like it. That's me personally. Once you're done, you'll hit home. Machine will index downwards and it'll learn that value. When it's done learning, it'll go back up to where you taught it, and at that point you want to make sure that there's no shell plate engagement. Perfect, we just learned it. Let's do primer setup. Primer setup also doubles as control seat. They're both the same thing. The best way to think about this is setting a waypoint or a node at the bottom of your stroke where you could use it for brass trimming if you wanted to go really fast, and right when you engage the brass it slows down and does a controlled plunge. Or the same for seating primers, or for decapping or swaging difficult brass. It's really a controlled feature that at the end of the stroke where all the load is taking place, when the tool head's down, you can kind of slow it down regardless of what speed you're at. So we're going to start. I really personally like mine to be roughly, let's get close, roughly there. That's where I like it. That's my own directive. I hit home. You can teach this value anywhere you want. You could have it at the mid-stroke. You could have it, you could have it one step under the full length. You can do whatever you want. There's no limitations. So we've taught everything. We're good there. Let's jump over and look at our clutch setup. Now, clutch setup is interesting because you got a bottom clutch and a top clutch and you have your stroke. So stroke is what we just taught. On this machine, it's 1,652 steps to get there. Our clutch value is 250 and our top clutch is 150. And what that really means from in layman terms is the machine will drive to the end like it's supposed to. And if it gets to the end and it doesn't see this lower prox, it'll drive another 250 steps until it sees it. If it gets to the end of the 250 steps to the prox, doesn't see it, it stops the machine, goes, hey, I have an issue. With this gearbox setup and this motor and everything, 250 steps is equivalent to the tool head moving a 30-second. I know it sounds dramatic, it's not. You can make this value larger or smaller depending on what you want for your accuracy or how robust you want your machine to be. So along the same lines, this does not increase torque, does not decrease torque. Your torque doesn't change at all. This merely is a limit for how long this can struggle to get to the end position. That's all it is. So I put a 250 for the bottom and I have a 150 for the top. That's my own prerogative. You can go all the way up to 1600 if you want for either values. Consider this a percentage of that. So we're going to change that. Let's say I really want that to be the same. I'll do a 125. I'm going to hit save. It's going to record it, and we're good. Last thing, for sensor setup, we already have the machine set up for a bullet sense and a swage sense. That's just my configuration that we had. But let's say I want to change that bullet sense to a primer sensor, and this sensor will correlate to this port on the box. So this is port 2, 3, and 4, and you can assign any sensor you want at will to those ports. You can use 2 bullet sensors if you want and have one look for brass and one look for the bullet. Feel free to do what you want. Now, by default, it'll be set to off, and what that means is you'll go into your main run menu, and it won't be active. It'll be assigned to the port. It's ready to go, and you can turn it on at a moment's notice in your run section, but it's not hot. So if we wanted that by default to be on during our load sequence, we hit on. So. And then same for swage. We have swage side, it's default on. We're just going to turn those off for right now, just because it's not something we necessarily we need to focus on. But we'll hit save. It's recorded, and we'll hit back. Now we've taught everything we need to get the machine running. So we have everything taught. We're going to go to our first menu for automation, which is going to be our semi-automated menu. We're going to hit the lower button, and the machine will home upwards. This is a normal function. It's basically cleaning the palette just to ensure that we're homed correctly. But you'll basically have the option to drive it to the top, the bottom, or the index point. The cool thing about this menu is that once you start motion, so once we go to the bottom, if I initiate motion and I hit top, the machine will go down and then back up. This menu is designed to help you with load development, with setting up your dies, with troubleshooting issues, debugging as well. It's really good for bullet pulling if you're ever curious. Ask me how I know. If you have to reseat a bullet, anything that's there where you need a little bit more control and functionality. So real quick, we were at the top already. Let's hit bottom, and let's say I want to go back to the top when I'm done. So we go to the bottom, and we go to the top. That's how it is. Let's say we want to just index the shell plate. I'll go index. I go up. Perfect. Now, real quick as a note, if you're doing brass and you have a clutch event where you basically, you have a failure of it to get all the way to the bottom, like here, we'll just show you. So we go down. Oh no, I stop it. We didn't make it to the bottom. We want to go to the top. The system can drive to the top and it'll stop when it sees the sensor. But if you want to keep going down, you can hit the bottom. It'll take you there. So a little bump is more from this press than anything, but it'll drive you down. Now, if you're ever in this menu and you reach an issue, like we just saw, you can hit the back arrow anytime, go to manual jog, go back, and then you're good. Now, it will rehome when you go upwards. Maybe that's something we'll fix or improve upon. We should take a note of that. But we're back to this menu again. So let's hit back, and we're good. So let's move into automation, the real automation side of this equation. We're going to hit our big button. We're presented with a few options. You have your load, round, how many rounds you want to do, how many rounds an hour you want to do, and then your advanced settings. For what we're going to do real quick, which is kind of I would say the quickest way to get the fastest way to load rounds, is we're going to change how many rounds we want to make. Let's say we want to do 25, hit enter. Let's say, 125 is great, but I'm bold. So I'm going to do 1,559 rounds an hour, and I'm going to load. The machine's going to home upwards. It's already homed. You can see on the screen you have a run button. When you hit run, it runs. It'll change to a pause state. You hit it to pause. There's the logic. The blue 0 is how many cycles we've done. The cycle is down and up. And then the 25 is how many you told it to do. And at the bottom, we have our top and bottom. This is your actual positional readout. Basically, if the machine is, how much does the machine compensate at the bottom to get to the sensor. So right now, from our previous run, we were at 7. What 7 correlates to in this world is really equivalent to, it's not even funny. It's maybe like 10 thousandths, or 1/10 thou. So it's massive. And then we have our advanced settings button. We're going to run this and we'll come back. Now, if you get done with this menu and you want to get out of here while we're loading, we can hit the back arrow. But I'll show you real quick. We'll just hit run. Now let's say I just want to pause it. It'll run. Now if I will go down, again the pause will stop it to stop it or do one stroke. And we saw we round counted up. Now let's do real quick an e-stop event. Let's just say something's happening and it might go running and I am just not happy, right? Something's wrong. I got to catch it. I don't know. The machine will stop. We'll go to an error screen. It'll e-stop. To undo an e-stop event or any error event, you have to cycle the emergency stop button. It's just the way it's going to work. If it's not pushed in, you're going to push it in, and then you're going to twist. It'll unlock. Screen goes away, and you're presented with a manual jog menu. This is the same manual jog menu we've used before. The only difference is this back arrow does not work. You're trapped. So you hit 50. We're going to clear our air. We're going to fix something. This die was low, whatever. And I want to finish what I was doing. So I was on the downward stroke. Let's finish what we were doing. Maybe I was on the upper stroke. I don't remember, but you get the idea. So let's finish our load. Going down. We just finished it. We added to it because we just completed. Let's hit run. So real quick, now let's say we don't like that index and we want that to be a slower index. I'm going to hit the advanced setting button. It's going to come up to the top and it's going to take us to our advanced setting menu. Right now with this system, we have to wait for the machine to stop motion to change any advanced settings. It's a safety precaution. But real quick, let's start at the top. You see that we did assign, if we remember, the primer sensor was on port 1 and the swage sensor was on port 2. They are present. They're off. If we turn them on, they turn green. We're not using them. They're not plugged in, but they're there. We have a temporary clutch button, which allows you to modulate your clutch values on the fly if you wish to. And you have your control seat. So real quick, we want to change our index. We'll take it from 100% index to 50% index, and then we're going to do what's called single stage. And single stage, we'll do one cycle and wait. And we're just going to hit the back arrow. We'll hit go. Waits for us to go. I want to change that. Let's take off single stage mode. Let's go to 75, and then let's do controlled seat. Hit back, hit go. Oh, this press just needs more love. So again, let's say we want to change those. We don't really need control seat anymore, and I just want to go full speed. Now, let's say we're running and I'm just done loading. I'll hit the back arrow, and the machine will exit what it's doing. It'll zero it out, re-zero your round count. It'll keep your speed. So real quick, we're going to pivot to the advanced run. Let's say you want to change some other things. Let's go real quick. Let's just do another 25 because it's a good pattern. Let's change this value. I don't know. Let's just be random. Let's do 1936. Good year. And then let's hit advanced settings. So advanced settings, you have your top delay, bottom delay, cutoff distance. You can start your index speed at wherever you want, and single stage mode. So let's make our top delay, let's just say, 159 milliseconds. Let's make our bottom delay, a full second, because we just got a lot of powder. So that's 1 second. I don't want to temp clutch, and I want to do 50%. I can hit the load button here to progress the loading, or I can hit the back arrow and hit loading. We're just going to hit load here. Machine homes. Here's our delay. Let's change that. I want to go to 100 now because I'm brave. And control C. Now, if you decide that you don't really want the dwells anymore, delays, you do have to exit the load like we just did. We'll go here. Let's say let's just turn it off because we don't want to. Got to put it back to 0. It'll retain these values as your set points until you remove them. Do 0. We'll hit load. But I didn't put a round count in there. The machine by default, if you don't enter a round count, will give you a round count of 101. We'll hit run. The machine wants to remind you that you need to hit those. You'll e-stop it. Machine will sit there. And now we're at 1. So now we have another error. This is an interesting one. This is a proximity sensor's loose error. Is really what this is. We'll just clear it. We'll just do 10 up real quick. hit bottom, hit run. Real quick, I'm just going to show an interesting error that occurs if you hit the proxies backwards, just so you can diagnose it. So real quick, I'm going to go to manual jog, I'm going to hit 50, and then I'm going to hit top and home. System is just home. I'm really quickly just going to e-stop it for safety reasons, just because I can. I'm going to flip my bottom and top prox. I know it sounds wild, but if you install these wrong or backwards, this is what will happen. So we're at the top prox, and what will happen is we'll hit the down arrow, and we can't go down. And what that really leads to, or what that means, well, it won't go down because I'll have to e-stop in. But if I hit the down arrow, it's not going to move. And the reason why is that basically this now is being seen as the bottom prox, and it won't move anymore. Now, if I hit the top, and I'm just going to be a little dramatic, at the top, it'll move still. So, because it has that capability. We're going to do a logic patch here to fix that in the future, but right now we're going to leave that as is. So if that occurs, you go to move it downwards and it doesn't. You want to flip your proximity sensors on the box. You can flip them on the machine if you want to, but I recommend the box. It's, you know, easy. Now we have flipped them. Let's just go bottom, home. Perfect. We'll hit top again. Just watch the cycle. You don't have to reteach the stroke if you already have it taught. It's really just if you have them plugged in wrong or something happens. We all get that. Last note, if you ever move a proximity sensor or adjust something else, you do have to reteach the stroke. That's kind of the best way to think about it. If you touch these in any way, shape, or form on both this or this, that's going to drive you to want to reteach the stroke. You don't have to reteach the stroke every power cycle. You just have to do it if you change something on the physical setup. That's really the best way to think about it. So, perfect. Let's go back, and that should be it.